Okay, now binary search tree deletion. So basically three cases are there. In case one, if it is a leaf node, so if you want to delete this particular node, you just delete this particular node, and in this part you just put null value. Okay. And second case is what, if a single child is there. So if you want to delete this particular node, so here you just put identify this particular part, and here you just link this particular part. And third case is what, if two children are there, 10 and 20, 10 and 30, and if you want to delete 20, then what to do. You can see here, suppose you want to delete a node. So here we are passing the root address of the root, that is tr. Okay, now enter the data you want to delete. Suppose you want to delete 10, so you just put the 10 value, and search function will return address of this particular node. That means z holds this one. Z is equal to null? No, it is there. So if it is not possible to delete, because no, that particular node is not present. Now you can see here, if z left child equal to null, z left child equal to null, the condition is true. Z right child equal to null, the condition is true. Y is equal to z. Now y is a temporary variable. Here we store address of this particular node. Okay. If y left child not equal to null, y left child not equal to null, the condition is false because it is null. Else x is equal to y right child. So what is y right child? Y right child, it is also null. So x hold null here. X not equal to null. No, the condition is false. X is equal to null. And yp is parent of y is equal to null. Now parent of y null. This particular condition is also false. Else if y is equal to is y is equal to left child of its parent, is y is left child of its parent. Parent is what? This 20. The condition is true. The condition is true means in parent of y, left child of parent of y, left content of parent of y, put x value. So yp, y is this one, parent of p bar, this one, and its left child means this particular portion, put x here. What is x? X is equal to null, so put null here. Okay, then return y. We can return this one y, or we can write delete or free y. Okay, so we can write free y. Now suppose we want to delete the data 30. Clear? So delete node 30, enter the data to delete 30, and search result will return the address of this. So this is nothing but our z. Z is equal to null, the condition is false. Now z left child equal to null, z left child equal to null, no, condition is false. Z right child equal to null, yes, condition is true. And since it is odd, so y is equal to z. So this is nothing but our y. This is nothing but our y. Now if y left child not equal to null, y left child not equal to null, the condition is true. X is equal to y left child. So x store address of this particular node, because left child of y is what? This one. So this is nothing but our x. X not equal to null, condition is true. Now parent of x will be now parent of y, because if you want to delete this particular node, now the parent will be what? Parent of this 30. So parent of 30 is what? This particular node. So here we just store, here we store address of this particular node. Okay, next yp equal to null, parent of y equal to null, no, the condition is false. Now is y is left child of parent of y, is y left child of parent of y. Now the condition is false. So in right part of this particular 20, you just put the parent of y. Parent of y means what? This one, and its right child part, right RC part. RC part means what? In this particular part here we store address of x. What is x? X is this one. Now suppose you want to delete this particular node, so in this particular part we have to store address of this particular node. So is in the parent part of right child part of the parent of y, you put the address of x. Okay, now if y not equal to z, y not equal to z, now the condition is false because both are same thing. Don't do anything, it will return y, or you can free the y part. You can delete this particular part. Now we can check once again. Suppose 20, 10, 30 and 25. Now here passing the tr value, this is tr, okay, and search this particular key. Suppose 20 you want to delete. Now z is equal to this one, okay. So search result return the address of this particular node, that node you want to delete. Now z is equal to null, the condition is false. Printf, now z left child equal to null, the condition is false. Z right child equal to null, condition is false. So execute the else part. Y successor of z, what is the successor of 20? Successor of 20 is what? 25. So y is equal to successor of z, so this is nothing but our y, because successor of y is 25. Please refer our previous video to know the successor function, the working principle of successor function. Next, left child of y not equal to null, the condition is false because left child of y is null. So x is equal to left child, so x is equal to holds the null value. Okay, so left child of y is what? Not equal to null. Left child of y not equal to null, the condition is false. So x is equal to what? Right child of y. So right child of y is what? Null. So x, the content of the x is null. X not equal to null, the condition is false because x is null. Now y parent of y is equal to null, the condition is false because parent of y is what? 30 is there. Is y a left child of the parent? The condition is true. Then parent of y, so in the left part of the parent of y, put null here. So you just put null here. Okay. Now y not equal to z, the condition is true because z is equal to this one, y is equal to this one. So transfer data from y to z. So the y data is 25, the z data is 20. Transfer data, now it is 25. Okay, and free y, delete this particular part. Now if you want to delete 25, now the tree is 25, 10 and 30. Okay, that means suppose 20, 10, 30, 25 is there. You just identify the successor of this 20. The successor of 20 is what? 25. Update this particular value and delete this particular value. Clear? Now you can take another situation. This is the situation, and if you want to delete this particular node, so both the children are there, identify the successor. So successor of 90 is what? 110. Okay, now here you just identify the x value. Now this is the y, this is the x. In left part we put the address of 120. Now there is a connection in between this, and update this particular node, content of this particular node, and transfer this particular data. Now it is 1110, that means you have deleted 90, and delete free this particular part. Okay, that is it. binary search tree deletion.